Alright, this process that these unstable isotopes go through, we talked about the types of radiation. Let's talk about how we can actually use this radioactive decay for some of our human benefits. You should remember that radioactive decay is when a radioactive atom emits an alpha particle, beta particle, or gamma rays, or a couple of other types of radiation in order to become more stable. This is the process of this becoming stable is called radioactive decay. Radioactive decay typically causes an atom of one element to become an atom of a different element by changing its atomic number or going through transmutation, either losing protons or gaining protons or something such as that. So we are becoming more stable through radioactive decay. Alright, half-life. The half-life of a radioactive isotope is the time that it takes for half of the particles in the nucleus to decay. So how long does it take for half of your sample to become something else? For example, if I have 10 grams of something, 10 grams of a radioactive isotope, how long does it take before 5 grams of it is still radioactive and the other 5 grams are something completely different? How long does it take for half of it to become something else? Or if you want to consider this, half of the radioactive isotope to go away. Okay, Half-life typically has some problems associated with it, and I like these problems because they're they are logic problems. Sometimes you really don't have a set formula, even though we can certainly apply certain parameters and parameterize some problems. We can apply that to these situations, but I kind of like using logic to solve them because it makes you think, and I like when I make you think. All right, so let's look at a half-life problem example. Palladium-100 has a half-life of 4 days. If you started with 20 grams of palladium-100, how much would you have after 12 days? Alright, so it says that every 4 days, half of this palladium-100 changes into something else, or half of the palladium-100 disappears. So after 4 days, if we're starting off with 20 grams, after 4 days, we would only have 10 grams of palladium-100 left. After another 4 days, we would only have 5 grams of palladium-100. After another 4 days, for a total of 12 days, we would only have 2.5 grams of palladium-100 left. So it's kind of a nice little way to, it makes you think how much is going to be left after so many days. If I start off with 20, half it in 4 days. Then 10, I have to half that in 4 more days. Then I've got 5, and if I half that in 4 more days, then I end up with uh, the amount I'm looking for, the 12 days that I'm looking for. But we could go on and on and on with this. 4 more days. So in 16 days, I would have 1.25 grams of palladium-100. In 20 days, I would have 0.75 grams, and it would go on and on and on forever and ever and ever until that palladium-100 is so small that it can barely be detected. So, how do we use half-life to help us in certain situations? Well, carbon-14 dating. Carbon is almost everywhere in our life, and we have several different isotopes, as we talked about in the previous chapter of carbon-14. We have carbon-12, which is our most common isotope, and a few percentages, or a little percent, small percentage of carbon-13 and carbon-14. Okay, carbon-14 has a very, very long half-life. It's 5,000 some odd years. Okay, we use carbon-14 in determining the age of fossils and various other things that we have associated, even like if we're trying to authenticate a historical document, like if you're looking at something in history and you're trying to determine how old this document is it really of the same age? We can look at the amount of carbon-14 in it, and actually the other isotopes of carbon and the nitrogen surrounding it, and find out how much or how old this was or how many half-lives it's been, so we can give a rough estimate. Do a little bit of math and it's there. So that's kind of how we use carbon-14. Carbon-14 is everywhere. We can look at the amount of carbon-14 that is there, as well as the other substances that's near that carbon-14 or near that object. We can do a little bit of math, or kind of like a reverse half-life problem, and determine the age of something. Other uses of radioactive elements: we use radiation in medicine, obviously, to locate tumors or to locate problems. You may have even yourself had radiation injected in you, and used to find a problem that you may have been having throughout your body. If any of you know someone that has ever had cancer, they use radiation to treat tumors. It's also used in agriculture to treat the feed, to enhance the growth rates of animals. Also, if you ever stocked a fish pond with like those grass carp, sometimes they will use radiation to sterilize them so they cannot reproduce and overcome the population of indigenous fish. That way you just don't have a bigger problem there. It's also used in industry. We send radioactive isotopes through pipelines to determine leaks, L-E-A-K-S, to determine leaks um, for like the big gas pipelines. You may have heard of an X-ray tech on a gas pipeline, and they're sending radioactive isotopes, and they're using these big machines to determine if any of that radiation is seeping out of the pipes or if it stays into the pipes. So that's just a few common uses of radioactive elements.